Okay, so here are my data of iris species, versicolor and setosa, the petal length. Now I'm just going to create my dummy variable, so I will insert a column over here. This is going to be my X. So dummy, and I can enter 0 and I'll copy that down. Now I'm not sure if I grab this and pull down, yeah, see it wants to count up. So I am just going to copy that and paste a bunch of zeros in here. So there we go, and paste. And then I want a 1 for these, and again I will copy that 1 and paste it all the way down here. Okay, so there are my X and Y data. And I am going to highlight all those, my X's and Y's, and copy that and go to my template, and I'm just going to go over these and paste, and there we go, my dummy variables petal length. Okay, and now I can fill this in. Again, I have to do it every single time, so equals line est. I need my y values first, so that's the length. There we go. And then comma, and I'll highlight all of these for my X's up to there, comma 1, comma 1, close off that parenthesis, and remember to do Control Shift and enter, and there we go, and we get an intercept of 1.464 and a coefficient of 2.796, so about 2.8, and that's our slope. We have a very, very tiny t value, or p-value from our t distribution, very much 0, 10 to the negative 62, and so they're definitely different. Now let's check. What I said was this intercept should be the average of these, the first one, the setosa. And so I'm just going to type here setosa average, and I'm going to compute that average, so average, and go get that. Okay, so there I have that. Close that off, hit enter, and 1.464. So there's the average. Then my versicolor, okay, versicolor average, and so equals average, and I'll go down here and do that one, close that off with a parenthesis, hit enter. Now 4.26, so let's check the difference. And that difference is equal to that 4.26 minus that 1.46 and 2.796. There it is. So you see, when we use the regression to do this with a dummy variable, so a single dummy variable, but these two levels, 0 and 1, then we can, instead of using an analysis of variance table, we can simply use regression. Now, this p-value, 10 to the negative 62nd, I don't know, I may regret doing this, but let's see if I can find my analysis of variance template, if I can find something like that. Actually, I should probably look in maybe back here in this one. I don't chi-square. Oh, am I in the wrong spot? I am. Okay. There we go. ANOVA. Yeah, see, I don't see my ANOVA template right there. That's where it should be, but that's so I can be pretty bad at bookkeeping at times. If looking at this, I don't see it there anywhere, but I do have a statistics template, a general one, and so I'll try opening that up. And it's got lots of different things. So here's the analysis of variance, and let's try placing our data there. Okay, so here's the first one with that length. I'll copy that and place it in here. Now I'll probably have to let's see if I have to get rid of, yeah, see, so I had much more data than that there. So get rid of that extra data. And I'll get rid of that data down there, so I know that's gone. And now let's go back here and get the rest of my data for the other type of iris. Copy and paste. Okay, and notice there it gives the averages, the numbers and so forth. And look at that p-value. It's kind of small there. Maybe I can make that a little bigger. 5.7 times 10 to the negative 62nd. And if we go back here, again, 5.7 times 10 to the negative 62nd. Same p-value. We ended up solving statistically the exact same problem. And this is where the regression can be extremely flexible. It's very inflexible in that it's only looking at straight line relationships, but if you trick it the right way, it can do fantastic things. And so here we tricked it with the dummy variable 0 and 1. Those are important values, the 0 and the 1. That's what allows us to get the kind of slope answer and be able to interpret it as the difference of the means and so forth. So that is very important. Using like 0 and 10 wouldn't, it would give different answers. Same p-value, I believe, but different slopes and so forth. So here, here is a way to sort of trick regression into doing an analysis of variance problem. As long as we just have the two categories, and we go with this dummy variable, a single dummy variable of 0 and 1. Okay, so there we go. There is dummy variables and analysis of variance using regression.